All right. So we are, unfortunately, just to be the standard trophy math class, we are a little bit behind some of the other classes. So we're going to be trying to work through most of what we can get through with 2.2 today. We'll wrap up 2.1, try and get through 2.2. If you have seen the weekly agenda, it says that we have a quiz tomorrow over 2.1 and 2.2. We're not going to finish 2.2 today. Quiz is going to be on Monday instead. It's not really like math intensive. You're not going to be calculating anything. It's mostly just, can you apply the vocab that we're learning here? Yeah, Nathan. Yes, of course. All right, so don't stress about it for tomorrow. And again, it's just going to be like vocab. It's going to be, do you know like quantitative versus qualitative? Do you know what we're about to talk about here? And then we'll be looking at like sampling and different ways to do sampling. So where we left off yesterday, we were looking at our different kinds of data, different kinds of variables, looking at our qualitative variables and our quantitative variables, and then we further broke down the quantitative variables into the discrete and continuous. Did we start talking about levels of measurement, or did we end by talking about like the population sample stuff? Perfect. Very good. Or I guess ending on this example here. Cool. So we're going to be starting off with today and kind of wrapping up 2.1 is another further way to break down the type of data. So we have qualitative, we have quantitative, and then there are levels of qualitative data and there are levels of quantitative data. I am going to be referring back to our Tetris example kind of at first, so just to prime ourselves. We were looking at 3 different variables for particular Tetris blocks. There was the color of the block. There was like how good the block was. So like, are we excited to see it? Is it good? Is it okay? Is it bad? And then there was like the number of squares that the block was comprised of, which is not a particularly interesting metric. I think most of it is 5, with like a couple of them being 4, but certainly like information that we can get. As far as our qualitative, quantitative breakdown, which of those 3 variables did we decide were qualitative and which were quantitative? So we've got color, a measure of like how good they are, and then a number of tiny squares that they're composed of.
Quantitative is the number.
Yep, so quantitative is like the number, right? We're doing like some kind of count or some kind of like measure of something. And so we end up with number of squares. Very good. And therefore qualitative is color and how good the other 2 are. Now, when you're given things like how excited are you about this course, or like on a scale of 1 to 10, tell me something, that is also falling under that kind of qualitative metric, where we can kind of superimpose value or order to the different options. It is better to be good than it is to be okay, and it is better to be okay than it is to be and so we can see already within our qualitative variables that they are not entirely the same. right? There are some qualitative variables that are different than others. It doesn't make sense to say that blue is objectively better than red, but it does make sense to say that getting a good block is objectively better than getting a bad block. All right, this starts to get into our levels of measurement. The first two that we are going to look at are generally ones that we are going to see attached to qualitative variables. Although we'll see identifying what is and is not a qualitative variable is maybe a little bit difficult. So first and foremost, nominal, coming from the Latin word for name, is really just simply, this is like our color example, we're just breaking apart into categories, and those categories don't have like value or importance over them. So for instance, getting a block that is yellow, beyond any other kind of attachments that we have to that block or to that color, is not any really functionally different than getting a block that is red or getting a piece that is blue, right? That color doesn't affect anything to do with the value. It is simply a category that we can place this in. So we might describe nominal data as being, I would say, purely categorical, where it doesn't make sense to rank the particular categories. Like, there's no reason to put blue above yellow. There's no reason to put red above green. That would just be arbitrary and wouldn't really serve a purpose. Examples of this, again, nominal coming from name. If we're just naming things, like for instance, if I'm looking at your class schedules and that's the variable is like what kinds of classes are you taking, then the nominal data from that would just be like the names of the classes, right? Taking statistics or taking biology or taking English or taking history, barring our own kind of impositions on that framework, that doesn't have any particular need for order or need for structure or anything like that. It's just names. So this could be like naming. We see this a lot when we're talking about colors, but just essentially anything that is merely describing, not trying to make value statements about what we have. Nominal is to name. Ordinal is going to be referring to the fact that, yes, we are still talking about categories, but now there is an order that matters. There is a rank to what we are looking at for our categories. So this is categorical, but with ranking. All right. We already saw the one example with the Tetris pieces, which is like how good the piece was. It's better to be good than it is to be bad. That there is rank there. It's not the same value being within one category or the other. So we might call that like a quality assessment. We looked at another example yesterday where we had a qualitative variable that was not just random buckets that didn't have meanings, that were just names. What was the qualitative variable from Mr. Spencer's class that carried with it some kind of numericalness with it? The letter grades, right? The letter grades weren't literally numbers that were the grades, right? It's not a quantitative value, but getting an A is different than getting a B in a way that is different than being like red versus blue, right? It actually represents something. There is an order that we can make sense of to having preference over getting an A versus getting a B versus getting a C, what have you. So letter grades was a really good example there. Right? It's not just names. It's not just called A. There's a reason why it's called an A. And these are things that we can generally put like that numerical overlay on top of, right? A has numerical meaning to us. We know that that means it lives between a 90 and a 99. We don't know the exact measurement, but we know it lives there. A surprising one, and the last one we're going to look at it as just like this generic example, is that we see this with ranking in terms of like finishing first versus finishing second versus finishing third, like for a race. That one starts to feel like it might be a little bit quantitative, but like finishing second doesn't mean like we have 2 first places. It's not like having finishing third is like 3 first places. It's instead kind of describing the position where this individual is finishing. And because it's like this descriptive variable rather than being like a numerical measure, again, not that we can't put a numerical value to it. If this is a race, we could put a time to that placement. That would explain the placement. But the placement itself is a bucket. It's not like a value that we are measuring. So like first versus second versus third, again, maybe starts to feel a little bit like it's getting into the quantitative area. And that's certainly true. A lot of these ordinal variables kind of tend to bleed. There's like a quantitative element to a lot of these. Or there can be. We can put one on there if we want to. So questions about nominal versus ordinal. Nominal for name, ordinal for order. Okay. The other 2 levels of measurement are ones that we're only really going to see with our quantitative data. Quantitative. Cool. Quantitative data. And it's a little bit difficult to like fully the difference between these is a little bit weird. Nominal and ordinal are nice because like nominal name, ordinal order. Interval and ratio don't, to my understanding, have a particular reason why they're called interval or ratio. Like those are math terms already. And they don't really seem to tie all that directly into how these are used. I'm sure that's not the case. I'm sure there's a framework for which it makes a lot of sense that we use interval here and we use ratio here or whatever. But there's like a really, really simple way to kind of address this. And it has to do with how these variables use specifically the number 0. So interval is going to be, because it's quantitative, there's kind of this implicit ability to order or rank the information that we are measuring, like getting a 1 versus getting a 3 versus getting a 5. Those are like fundamentally different and rankable. So we can say like order or rank matters, but that's really more just because what we're looking at is a numerical value. The same is going to be true for ratio as well. Like that is not the difference between the 2. That's just a consequence of the fact that we are dealing with quantitative variables. And the thing that's different between interval and ratio is that 0 for our interval level does not mean nothing. Okay. What on earth does that mean? 0 does not mean nothing. Let's consider an example. I think the IQ test example, we'll talk about IQ test here in a second. I think a phenomenal example to describe this is temperature. What does 0 degrees Fahrenheit mean? It means it's cold, right? That's literally like Fahrenheit went outside. He said this is the point where I think it's really cold, and he labeled that 0 degrees. And then he said, this is the point where I think it's really hot, and he labeled that 100 degrees. And that is the metric system that is the Fahrenheit system that he constructed that was oh so proud of. Very cool. Not particularly, robust, but that's fine. In that case, does 0 degrees mean that we have no temperature? No. It's just like an arbitrary benchmark for a particular temperature, right? And it can convert into something else. Likewise, 0 degrees Celsius. Does 0 degrees Celsius mean that we have no temperature? No, we still have a temperature, and it's maybe a little bit more sensical, the temperature at which water freezes. But it doesn't mean that the temperature is just not there, right? It's like you guys said, it's not that there's no temperature. The temperature is cold. It is not that we go out and it's just like that perfect 72 lukewarm where we don't feel anything. 0 does not mean nothing. Now, 0 degrees Kelvin, that 0 actually does mean an absence of something, right? 0 degrees Kelvin is no atomic movement whatsoever. It's called absolute 0. There's literally no friction, no anything. The molecules don't move at all. That would be an example where 0 is actually an absence of something. That might be ratio. But certainly the way that we standardly or normally measure temperature with Fahrenheit and Celsius, that would be an example of interval. 0 does not mean nothing. Right. Another good example would be intelligence testing. If someone were to score a 0 on an intelligence test, it does not mean that they are not sentient. It does not mean that they are a rock. Instead, it just means that they got the lowest possible score for intelligence. Right? It's just the absolute minimum value that they could have gotten for what we see. Right? So it doesn't mean that there is nothing there. It just means that it's a low score compared to what they could have gotten otherwise. On the flip side, ratio is going to be where 0 means literally that we have nothing. Right? So for instance, if I do a count of the sweatshirts and I see that there are 0 sweatshirts, that 0 sweatshirts doesn't mean anything silly or arbitrary or anything. It means that I don't have any sweatshirts, that there are no sweatshirts. So counting is a great example, right? Like counting objects. If I have 0 blue M&Ms, then I don't have any blue M&Ms. It doesn't mean anything crazy. It doesn't mean anything special. We can also see this with like numerical representations for like height or weight, right? Having a height of 0 just means nothing, right? Having a weight of 0 means that there's nothing there. And one final little mini example, age, 0 years old means that you have not yet lived a full year. Right. Questions on our definitions for these levels of measurement. All right. Messed up my thing. Let's take a look at this example here. I'm going to give you guys about 5 minutes, talk amongst your group about this. All we're trying to do is classify the data types that we are given based on the level that we would think. A couple of these are a little bit tricky. So again, think, how are we using that variable? What does that actually represent? And try your best. Take, again, like 5 minutes, and then we'll take a look. Wesley's not here today. And what's his name? Okay. Cool.
Wait, no. Yeah.
Okay. So we've done a couple of these. It's just like, so let's take a look at it. Is there one in particular that we're struggling with? Okay. So let's take a look at, we'll take a look. So what are like the different options for analogy that see from like they're really only two, right? I guess we can three. Yeah, I guess we're not married. I guess like divorced is probably technically America says. Is there like an intrinsic, without our own like supposition? Is there like more value in married or being not married or divorced? Is there like a reason why salary is in front of like class? Or are these just names that describe what's going on? Yeah, they're just kind of names that describe what's going on. So which of these four categories? $0 nominal, so that you're near the set money.
Yeah, there's also saying like water on it.
Let's take a look at another. Salary. So salary, what kind of like a no amount of money. So probably some kind of where we're going to have like something, which is good. And what would it mean to get a salary out of it? So as soon as we have that, we're going to kind of what does it mean to have a salary? Because having a salary of 0 means we're getting.
No, I thought we're talking about letter.
Okay.
To be honest, usually an example.
Let's take a look at zip is highly expensive. So like what is your so that's like a number. So it feels like that one should be quantitative. This is the number, right? How are we using that number? What is that number doing? Is it like telling us how many of something we have? Is it like having the zip code of 307 mean that we come in for the zip code that has like 308? Are we using it as like a number, or are we using it to do something? So what scale? Let's do something else. What does your zip code tell you? Why are you going to do a list here?
Quality rating.
It's like where you live, right? It's like a placement for the name of a zip. So having like a zip code is like the same thing as saying I live in Colorado.
quality.
So how are we
scale.
using
I feel like it does.
It's basically like
Why would you do quality on?
is it like a name or an order with it, or are we using it like numerically?
It'll be
Kind of-
nominal. It'll be ranking.
Yeah, so you know, if you ordinal, it'd be ordinal, because nominal is not ranking.
So it's kind of the same as like a name,
Oh, yeah.
right? It's like the same. So that's like a trick. There's another one on there that it's a number, but we kind of use it like a name. But those are those.
Are you sure it's not just you roll?
Yes.
No, it's just like,
This is.
I mean, because they either have a global where it does change into the ranking.
So we don't need to worry, well, so you can, are you gonna break this into two steps? You could first identify, is it qualitative or quantitative? And then you can further break it down for, is there order, or is it just naming things, or what is it? Or like the ways that we look at it.
Oh, I didn't put that on. Oh, that one's.
Yeah, so marital status is just like, it's just a descriptor, right? It's just a name for someone. So it's like a blanket that they fall into. It's not like being married is better than not being married. And so it's just. So order, what would an example be? Just that
He's going up.
Look at.
Yeah, he's going
Yeah. Where order is. So does it matter that you have jersey number 13? Yeah, so order actually does, which is interesting. Yeah, college basketball ratings would be a really good one, because that's being like, if you're the first pick,
Yeah, it's not.
that is better than being second. Or there's like a value difference.
That sounds stupid.
And that one starts to get a little bit close to like feeling quantitative, but the whole like ranking system is gonna be.
Just going to the same time.
Yes.
Every time.
Yes.
Like rating it does, it just goes down.
We're gonna take a look
Because qualitative is like category.
Like, let's bring it.
at.
You know, the same time.
I think that.
You know,
Yeah, but it's like just the truth.
Okay. So we filled in a few of these already. I'll go ahead and mention the ones that we already did. We did IQ score, which we said was interval. Yeah. So this is IQ. What's a similar thing up here to IQ score that's like measuring intelligence? ACT score is also probably pretty similar. I don't think you can get a 0 on the ACT, but again, like getting the lowest grade on the ACT does not mean that you have 0 intelligence. It just means you scored the lowest possible score on this test. Okay, so we did those two. So that one's not bad, yeah. We did height and weight already, although actually I want to revisit height. So height is assuming that we are taking a quantitative measure, right? Like I measure someone and they're 6 feet tall. That's the quantitative measure. How could I look at this variable instead of being quantitative as being qualitative? What's a qualitative way to measure someone's height? Tall or short? Yeah, so looking at or ranking in terms of tallest to second tallest to shortest. Both of those are really, really good ways. If I'm doing tall, average, kind of short, short, what kind of measurement would that be? That would be ordinal, because it's buckets that have some kind of order, right? There's something to those, but the way that we will generally measure height would be ratio. But it is certainly possible to see ordinal measures for some of these values. All right, very, very good. Eye color, we talked about color. What's eye color going to be? That's nominal. What about, we said letter grade was ordinal. Okay. Quality rating scale, that was like the good, average, poor, ordinal. Right? Being best is better than being good, kind of a deal. And then temperature we said was interval. Yeah, very good. Okay, I think that's most of the ones that we had already covered. What would we have for gender? Definitely nominal. Very good. Take a look at a curveball. Zip codes. Zip codes are tricky. What kind of value will our zip codes take the form of? They're numbers, which leads us in the direction of thinking that these are what kind of variable? Quantitative. That's not bad. But how are we using these numbers? They're descriptors. They are telling us a place, right? I could give you a zip code of 38017, and I could give you the city of Collierville, and those would be the same thing, right? That's the same measure, that's the same variable. So this is a number that is being used in place of a name. So what kind of data do we have for zip codes? That is nominal data. Similar idea. What else is up here that uses a number like it's a name? Football jersey numbers, exactly. Very good. So those two are the like really, really tricky ones of like, yes, it's a number, so it feels like it would be quantitative, but the order of the number doesn't really matter, right? It's not like 38018 is better than 38017. It's not even like they're necessarily next to each other. It's just that they are using similar numbers, right? It's a similar area code. One is not better than the other. They are being used like a name, which is tricky. That one is certainly tricky. Marital status, what would we say? I would definitely say nominal. Okay. What about grade level? So I think this one's kind of close to either being ordinal or nominal. I think if we think in terms of like, is there like an intrinsic value in having, say, like being in first grade versus being in second grade? I would probably lean nominal, but I definitely could understand ordinal, right? Because it goes in a progression, right? First grade, second grade, third grade, fourth grade. There is some kind of order there. So I'm actually kind of split between those two. I'm going to list it as, I've been listing it as nominal, but I'm a little bit on the, I might get that one wrong as well on a test. That one's tricky. All right. What would salary be? Ratio, because what does it mean to have a salary of 0? That you have no money. Very good. College basketball rankings. Like first pick, second pick, third pick. Ordinal. No, the difference that I would say between this and grade level is that like while being a first grader versus being a second grader, there isn't necessarily value there. There is value in being first pick versus being second pick, or being ranked number 1 versus being ranked number 2. Very good. Area and volume. I would say ratio. Having an area of 0 means that we have nothing. And then army ranks would be ordinal. All right, questions with our example here. How do we feel about our data classifications? Good. The number 1 zip code and jersey numbers, I agree. Those are tricky. That feels like it could be quantitative. Grade levels, I agree. That one's pretty tricky. But those are interesting instances where we're like using a quantitative value as a name. So like as a category. Importantly, it's not better to be number 13 than it is to be number 27. And it doesn't indicate like who joined the team first. It's just random, right? It's just whatever the player wants their number to be. Feel good on types of data? Quantitative, qualitative, continuous discrete is maybe a little bit tricky, but at least the gist. And then these level of measurements. Cool. All right, let us carry on then. Gonna jump to 2.2. Okay, so before, or 2.1, focusing on like the types of data, and then a little bit into like the difference between things like population and sample. Now we are going to be looking at how we actually get the data. In particular, we're going to be looking at how we do it well. In a moment here, I'm going to give you a demonstration where I do it very, very poorly, and then we're going to kind of like try and see how can we maybe avoid doing the thing that I did. All right. So we've done a little bit of this already in the context of Unit 1, just like seeing different ways that data collection has been described. What are there are three big ones. What are kind of the ways that we generally describe data collection? Or that we collect data, rather. Sorry, not describe, that we collect data. So surveys are going to be a good one. Very, very nice. What else? Yeah, well, so studies, we've kind of been using that word for like the correlation causation stuff. Studies or experiments. The reason I'm wanting to make that distinction is technically we could talk about a different kind of study that wouldn't work for causation versus correlation, but certainly how we have been using study or experiment work really, really well. And in fact, you might see it described as like an experimental study. Experimental. And one more. Kind of close to surveys, but a little bit different. Poll and survey would be the same. So a little bit misleading on my part. What was I doing when I was like counting the number of people who are wearing sweatshirts? I was observing or tallying. That would also be equivalent. We might say that that is like an observational study. Which would not be enough for causation again, but we'll get there in a moment. We're going to skip types of surveys for now. We'll talk about some advantages and disadvantages here in a moment. I want to focus on the actual sample that we collect. Okay, so we have our ways to do this. Let's run an observational study here for this class. I want to have at least a guess as to the number of students in this particular class who are wearing earrings. All right. So I could go to every single student. That could be like a descriptive statistic. I go to every single student and see, are you wearing earrings or not? And then we do like just a total tally of that. I'm going to try and do this, though, without looking at the total population. I'm going to try and do this with just a sample. And we'll see if we can calculate. There are 20 people, I guess maybe 19 now, 20 people-ish in this class. I'm going to sample 4, and we'll just take that number and multiply it by 5, and that should be a pretty good guess. Okay, so let's run our sample here. Paxton, are you wearing earrings? No, cool. So that's no earrings so far. Dylan, are you wearing earrings? No. Ethan, are you wearing? No. Nathan, are you? Okay, no. So of my 4 that I have sampled, I have that 0 of them were wearing earrings. 0 times 5 is 0. So I would expect there to be no one in this classroom who is wearing earrings. That is my conclusion that I come to from this observational study. What did I do wrong? I only chose guys. And the probability that a guy is wearing earrings versus a girl is wearing earrings is probably not equal, right? Okay, so there was something fundamentally flawed about the way that I did my sample. In particular, I collected what is called a biased sample. So a sample is biased if, due to something that went wrong during the collection process, it tends towards something other than, or it's not reflective of the larger population. So a sample that fails to reflect the larger population due to how it was collected. All right. I did a pretty extreme example. I could have also surveyed like 10 girls and 1 guy, and that would probably give me an overestimate as to my predicted value there. Right? So this is obviously going to be very, very problematic beyond just the fact that a biased sample doesn't allow me to properly make conclusions. Now, this sample would not be biased if the thing that I were studying was the number of guys who are wearing earrings in this class, right? That would actually be a closer random sample to what we are seeing here. But instead, because of kind of what I wanted to claim, this did not do a very sufficient job. So the main kind of thing here, notice that the demographics of my sample did not match the demographics of my population in a way that was relevant. Sometimes those demographics aren't always going to be one-to-one, but in this case, it was by a very, very important feature of my sample that did not match my overall population. For instance, taking a look at this very, very simple example with just dots, what do we notice about the sample in comparison to the population as a whole? So we got 3, for our sample, we have 3 gray, 2 blue, 1 red. So it took all the gray ones. So for our population, we've got like 20 dots here. 3 of them are, what, 3 of them are gray? 3 out of 20 would be like 15%. So for our population, we've got 15% gray. We have 5 of our dots that are blue. So that would be like 25% would be blue. And then we have, what, 12 of the 20 are red. So that would be like 60% are red. And for our sample, what percentage of our sample is gray? 50%. What percentage is blue? 2 out of 6. So you did 2 out of the remaining 3. Yeah, you have to count the total. So 33. You're good. And then how many are red? We might not know. 1/6 off the top of our head, 16.6 repeating. We'll round it up to 17% just to make our numbers look nice and clean. And so we see gray is vastly overrepresented. Blue is slightly overrepresented, and red is vastly underrepresented. This sample does not do a good job at acting for what we would expect for the population. There are a couple of different ways that we could avoid this. We're going to talk about this particular sample a little bit more in a moment, and we'll look at some sampling tendencies that we can do that will help us to avoid things like this. But that is generally the gist of what we're talking about with bias. The demographics of the sample are not the same as the demographics of the population. As far as ethics and sampling go, this is a really, really bad thing to do. And it's a really bad thing to do deliberately. It's not necessarily something that is done deliberately, though. But if we were running a medical study and we knew that a certain type of patient was more likely to be receptive to our medicine, then running that study with only people who fit that particular characteristic doesn't necessarily make sense. You're welcome to look at it. Right. So there are a lot of kind of shifty ethics that we might see with this. We just need to be very, very careful as to whether or not we are correctly running the sample, which we will see how we can do that here momentarily. The most simple way to do this is with what is called a simple random sample. Rather than being very, very selective and choosy about what for my sample, we just randomly choose various numbers. An easy way to do this would be like to give every single person a number and then just randomly select certain numbers. Right. So individuals are randomly chosen. And very, very important here is that the likelihood for being chosen is uniform. For my sample before, where I was picking only guys, there was a 0% chance that I picked Liz. That means that this was not a random sample. It was simply a bias sample. It was a deliberately biased sample. So important to this is that all individuals have an equal likelihood of being chosen. All right. We could accomplish this again. I could assign numbers. We could run a random number generator, things like that. This is my little moment where I'm going to talk about cool technology that is needlessly precise, but it's also very, very fun. When you run a random number generator on your computer, or when you do like the Google like coin flip interface, or you do any kind of digital coin flip or random number generating anything. What you are getting is, technically speaking, not random. It looks random, and it's programmed to look random, but it technically comes from an algorithm. So, for instance, if you were to do the Google coin flip and you were to flip that coin and get heads 5 times, that feels really, really, well, one, it feels not random because, you know, you got heads 5 times. But let's say you flip it 50 times and you get 46 heads and, or no, that would be crazy, 27 heads and 23 tails. That starts to feel kind of random, and there doesn't necessarily seem to be like a pattern there. That is the computer pretending to be random. And it does a good job. It does good enough job at that we're not particularly concerned with the fact that it's not technically random. But when we are talking about computer-derived random number generators, the word that you will often hear is that it is a pseudo-random number generator rather than a random number generator, just because it's technically not random. There is some underlying machinery there that is causing what we see. If you understand the code, the outcome is predictable. It's not just completely luck. Now, let's say you want to have a coin flip app that is not pseudo-random. There is one that exists. It is called the Universe Splitter. Beyond also having other cool quantum mechanics implications, as the name kind of suggests with it being called the Universe Splitter, rather than having a computer generate heads or tails, what this does is it sends a signal to a machine in like Sweden or Switzerland or somewhere. That machine fires an electron at a mirror that has a 50% chance of bouncing off the mirror and hitting one receptor, and a 50% chance of passing through the mirror and hitting another receptor. And that is a true random 50% chance of bouncing off or passing through. And so your coin flip is actually random. Beyond that, because of quantum mechanics, technically the way it works is there's one universe in which you get heads, and then there's another universe in which you get tails, which is why it's called the Universe Splitter, which is just kind of cool. It is $3 on the Apple iOS store. Definitely not worth it for a glorified coin flipping app. I also use it all the time. It's incredible. So if you want to waste $3 on a coin flip app, that is definitely the one to do it on. All right, so we have our random sample. And we run our random sample. Is it possible that we would still get the sample that we see for this particular population by just randomly selecting dots? Is it possible? Yeah, absolutely it's possible. Is it particularly likely that we would get this? Probably not. We could calculate that. That would require some hypothesis testing and probably a new table to look at. But it's definitely possible. It's not unlikely. Is that because we did anything wrong with our sample? For just running a random sample, have we done anything wrong with our methodology? No, it's just unlucky. So that's entirely possible that I do the exact same thing. I give everyone a number, I do a random number generator, and I get the same 4 people that I deliberately picked to be biased, and that's just unlucky. The way you kind of stave that off is you do either a bunch of random samples, or you make sure that your sample size is large enough that that wouldn't really matter as much. For instance, if rather than a population of 20 dots, we looked at a population of 20,000 dots and looked at a sample that was, rather than 6 of those 20,000, maybe 6,000 of those 20,000, this result becomes a lot less unlikely to show up if we're doing this correctly. But we're also going to see that there are ways that we can be very deliberate, still run a good sampling, and also sidestep some of this bias that we might just get because we're unlucky. So we'll have a methodology to be able to deal with this. Okay, so a couple of specialized types of sampling. So SRS, simple random sampling, is just I randomly pick people. Everyone has an equal chance of being selected. Systematic random sampling is basically just fancy random sampling. There's not like a difference in terms of like the expected results that you would get necessarily. An example of systematic random sampling would be, rather than giving everyone a number and just picking random numbers until I have a large enough sample, maybe I give everyone a number and I pick all of the evens. Right? Or I pick every number that ends in 4. Or something along those lines. There's like a little bit more to the selection process than just like blindly throwing darts at a dartboard and seeing what I get. And so for systematic sampling, we might say like individuals. Holy crap. Individuals are randomly assigned a number, and every length one is chosen. So this would be like, again, giving everyone a number and choosing odds for our sample. Is this better than a simple random sample? Not really. It makes the data collection process a little bit easier to replicate. So you can be sure that any error that you're seeing isn't coming from the random nature of how you are selecting individuals. So it makes the process a little bit easier, but it doesn't give you like a fundamentally different result than what you would just get by doing SRS. Again, super, super, super important here is that the numbers are randomly assigned. So thinking back to like elementary school, where you're lining up and you're being picked for teams and you see that your friend is on team 1 and you do the quick count and you know that you're going to be on team 2. And so you nudge the person next to you and you really quickly, before the teacher can notice, trade places with the friend so that you get put on team 1 instead of team 2. That is not random assignment, right? That is you selecting what number you are going to get, knowing how the sample is going to be conducted. That's not random. Likewise, if I went and assigned everyone deliberately a particular number, like let's say I gave all the girls evens and I gave all the boys odds, and then I picked even numbers that are divisible by 4. Looking at earrings. Again, that's not random. That's not going to get me an unbiased result. That's going to basically just be doing what I did manually, but make it look fancy. Right? So the way to avoid bias is to randomly assign. But this doesn't really fix the issue that we were running into before of like, what if I give everyone a random number and then all the girls happen to get evens and all the guys happen to get odds? Not very likely, but certainly possible. So this isn't like better than a simple random sample. It's just a fancier simple random sample. Okay. So with my earring problem, we have identified a major potential source of bias. I could run a simple random sample. I could run a systematic random sample. There's nothing wrong with those. Those would certainly be steps in the right direction compared to what I did first. But what is always the possibility that I have to worry about that might introduce bias? What key demographic of our population seems to be causing us trouble as I'm conducting this survey? For instance, if I do a random survey or random sampling, what might still give me, what would an example of a biased population still be, even if I do my survey perfectly? Or my sample perfectly, rather. Okay, so maybe we're gonna talk about like demographics for like the actual surveying process here. Put a pin in that one. I just mean like in this, like I'm asking you guys, I'm taking a sample of, let's say, like 10 students. What would an example of a biased selection be that I could get? All female, or maybe like 8 female, 2 male, or maybe like 7 female, 2 male, or maybe like 3 female, 7 male. All we want to ensure is what? What would be a really kind of clean way? What would I like to see from my sample to feel like it might be emblematic of my population? We'd like to see half and half, assuming, of course, that the classroom is split roughly half and half. Right? So maybe we might need like 60-40 or something like that, but we would like the proportion of our sample to match the proportions, the demographics of our population. How could we accomplish this and not leave this up to random chance? That is going to be through what is called a stratified random sample. The way a stratified random sample works is we are going to identify an issue within our sampling that might cause bias. In this case, we're noticing that if we get a sample that has more guys than girls or more girls than guys, then that's going to bias us in some direction. Right? Maybe my survey is biased. We'll talk about examples. I'm getting ahead of myself. And so to combat that, I first group all of my guys and I group all of my girls. I have isolated the source of bias by creating these subgroups. And then I SRS my guys and I SRS my girls. Take random people from one group, take random people from another group, and my overall sample is now all of a sudden emblematic of the larger population. I do the sorting kind of ahead of time to ensure that my sample matches some feature of the population that I want it to match. In this case, we're talking about proportion of guys versus girls. All right. So for our stratified sampling, we are going to create what are called homogeneous subgroups from our population. Homogeneous just meaning what? What does homogeneous mean? So is this together the same? Yeah. So like all, like thinking like a homogeneous mixture is like all the same or all together all the way through, fully mixed. In this case, we're looking at a particular trait that is shared amongst every single group member that is not seen in other groups. All right. So creating homogeneous subgroups from our population and then taking an SRS of each subgroup. And SRS is again just our way of saying simple random sample. And it deals with the bias ahead of time. I no longer have to worry about having my random sample have too many of one particular type of demographic. All right. Another example is maybe we want to get a sense for how worried people in the school are about college choices. If I take a sample and get a bunch of freshmen just randomly in my sample, maybe I'm lucky and 50% of my sample is freshmen, that's probably going to bias me towards not being very worried. And if I take a sample and get a whole bunch of seniors, that's probably going to bias me towards being, well, also maybe not very worried. I don't know. I guess we're at the point where maybe people have heard back from colleges, but kind of also you would assume maybe a little bit more worried, more stressed. And so this is a kind of situation where maybe we want to ensure that we get results from freshmen, results from sophomores, results from juniors, results from seniors, and that none of those subgroups drown each other out. That we can see, like kind of hear the perspective of each of those subgroups. That might be one where we are interested. So this might be like dividing by like grade and then sampling each grade. Okay, so stratified, and I'm being very, very repetitive about this. I know, I'm sorry. The main reason why is because clustered is very, very similar for a lot of different reasons. So I want us to understand what makes stratified. So stratified, we're making different subgroups. The subgroup itself is not like emblematic of the population, right? The subgroup is separating out differences. And the reason why we separate out the differences is to ensure that every kind of piece of the sample represents people with those particular differences. Right, so we separate out freshmen from sophomores, from juniors, from seniors. We sample all of them so that we hear the voice of freshmen and sophomores and juniors and seniors all relatively equitably. Stratified sample here would be maybe we take our population of red dots. Their expected value was 60%, so maybe we pick 3 red dots. That gets us close to 60%. And then maybe we pick 2 blue dots. That gets us pretty close to that 25%. And then we pick 1 gray dot. That gets us pretty close to that 15%. Right, so we ensure that what we get at the end is relatively close to the overall population. Don't have to worry about luck. Different than this, but similar, unfortunately, is clustered sampling. Generally speaking, clustered sampling is not really something that we're doing because it leads to like a better survey. Often we're doing it because it's convenient. Not to say that we can't do it well and not to say that we can't get good data doing it. This is just kind of very, very much emblematic of like, oh, this is already predefined for me. It's already nice and good to run. We can do this. So this one becomes a little bit dangerous, and we'll see why here when we look at an example momentarily. All right. Like our stratified sampling, clustered sampling starts by creating subgroups of our population. But rather than creating subgroups that all like share a particular trait, like creating freshmen and then sophomores and then juniors and then seniors, we are instead hoping that our subgroup is a stand-in, it's like a small version of the larger population. We would like each subgroup to basically be a sample or a viable sample. These are going to be heterogeneous subgroups, just in that we are not trying to like pick out particular individuals. We want each group to be like a mini version of the population. So in this case, heterogeneous means like, I mean, it doesn't, right? It means like mixed up and different, but we're going to use it to mean that it's like the population. So we're creating heterogeneous subgroups, and we are using one whole subgroup as a sample. Again, this is generally because it's convenient. How might we see clustered sampling? Maybe we want to make some kind of statement about what's going on with Collierville schools. And so we look at Bailey Station and use all of Bailey Station as our sample. Mostly just because it's convenient. It's already kind of subdivided for us. Presumably the feature that we are trying to tackle would be similar in Bailey Station as it would be for like CHS, right? Whatever that may be. So maybe like using one school from a district as the entire sample. Or maybe there isn't a big difference, or we wouldn't expect there to be a big difference in responses from like freshmen, sophomores, juniors, and seniors. They're already nice and grouped up for us in seminar, and so we ask the freshmen to fill out a survey and assume that their results can be applied to all of the other groups and can speak for the population as a whole. Again, this is like convenient. But importantly, the subgroups that we are creating are not like all red or all blue or all gray. They are similar to the population, and then we're using one of the subgroups as the sample. Questions here about our types of sampling. So there's simple random, systematic random, stratified, and then cluster. Yeah. Before we take a look at an example, I want to go back just for a moment to the types of surveys. We're not going to really go through a full breakdown of like what the various survey types that we might see are and like advantages or disadvantages of each of them. I don't really want to get that like focused on it. Rather, I want to talk about a couple of interesting areas within surveying where the way the survey is presented can create bias. So it's not necessarily anything that's like wrong with the sample, but the survey itself, the way that it is given to people, creates bias. All right, two different areas that I want to kind of focus on. The first is the idea that a survey that is anonymous is more likely to give you genuine results. Particularly if the subject that we are looking at is a charged topic. If an individual thinks that they might look like a bad person for answering in a certain way, they are more likely to answer honestly if that answer is not tied to their name and their face. So for our kind of like things that are good about surveys, anonymous surveys may be more genuine. Makes sense, right? If I were to ask everyone what they think about this class, I am a lot more likely to get honest answers if I don't attach your name to that survey. But if you had to worry about whether that was going to affect how you did in this class, then you're a lot less likely to answer honestly. All right. The second piece, and this one's a little bit more subtle. This one's kind of interesting. Optional surveys also introduce a type of fundamental bias in that they don't generally get a lot of middle ground responses. So if we think about like if I give like a survey online, like let's say I post to Twitter and I say I want to see I don't know, whether or not we should rezone Collierville schools, something like that. I am not very likely to get a lot of responses from people who don't live in Collierville because they don't care. Why would you take the time to fill out a survey when the results of the survey don't affect you, or when you don't have a lot of vested interest in a particular topic? And so this kind of neutral middle ground, I could go either way viewpoint gets lost in these kind of self-completion surveys in a way that you don't necessarily see with, say, if you were to like make a bunch of phone calls and just say, I have one really quick question for you. What do you think about this? You might get a little bit more of people who are willing to kind of give their perspective. Even if that perspective is, I don't really have an opinion. In the optional survey, what you are garnering are people who are very, very passionate about the topic in one direction or another. So again, you lose some of that like neutrality, you lose some of that middle, and what you end up representing are the extremes on either side, which is just kind of a fascinating element to what we can see with surveying. So optional response. Surveys maybe bias to the extrema or extremes on either side of a topic. Right? If I say pizza is a sandwich, then people who look at that and are like, that's stupid, they're probably not going to respond. If I say pizza is a sandwich and that absolutely infuriates you, you're a lot more likely to engage. All right, questions with our kind of bias filters that we're looking at so far. I know it's a lot, almost done. One example, and then we will call it here. Okay, so in this case, we are trying to conduct a survey that talks about drug use in America, or particularly American opinion on drug use. Ideally, we would like this survey to include 3,000 adults and adolescents from all over the country. Again, we're trying to say something about how America feels about this particular thing. Okay, so thinking about like the type of survey that we might use. Again, we didn't really talk all that much about survey types. This isn't super relevant in terms of what we want to focus on. I would just think like in terms of this, would we think that anonymity for a topic like this might give people a little bit more comfort in being honest with their results? Probably, right? If you attach your name and your face to what you are saying about illegal substances, more likely than not, you are going to lean in one direction with how that conversation might go. That might introduce unnecessary bias. Likewise, this is maybe a fairly charged topic. So it might be one where, again, maybe self-reporting is a little bit difficult to get like a fully accurate view of, like, if people just don't really have an opinion, you might lose that in the midst of just the nature of the survey. So I think like maybe like a phone call-esque survey where you're calling random people from all over the country might be good. But also you could think of like maybe an online survey that can reach a bunch of people and can reach a bunch of people in a bunch of different places might be nice. A lot of different ways that we could conduct this that would make sense. But just important to kind of acknowledge going in, is the way that we are going to survey going to impact our results? If I do an in-person survey, I'm probably not going to get as honest a result as what I would see from another type of survey. Okay, so in order to kind of do our best to kind of use what we have, get a good sample, what would be a good way to go about sampling for this particular survey? Okay, random sample is like always going to be fine. In fact, it's not only is it like always going to be fine, it's always going to be pretty good. And the larger our N gets, the larger the number of data points we collect, the more reliable a random sample is. Or maybe we would take like a bunch of random samples, and that would also be totally, totally great. Similarly, systematic random sample would give us like very, very good similar results. Is there a setup that we could use that might give us an advantage to using stratified over random? I think random is great. Random will always be good. But is there a way that we could set this up so that maybe stratified gives us a little bit of wiggle room to avoid some bias? So what would maybe be a set of subcategories where we might expect to find like differences in response? Yeah, maybe amongst different races, maybe amongst different age groups. I think that both of those would be really good stratifications in order to build. You might want to build both. You might want to do like where the people live, like rural settings or urban settings. Second. Yeah, the laws in the region would be a really important thing to kind of understand. Maybe we do like a regional stratification and run with that. There are kind of a lot of different ways that we can do this, but if our data is large enough, if we collect enough data, we would kind of expect to hit a lot of those perspectives anyway. It would be a nice way to ensure that we hear the voices of a lot more people. But again, simple random is great. Simple random, nothing wrong with that. So really any of these are fine as long as we do it well. Okay, and then we have described for us a convenience sample, which is, kind of within the name, we can already probably tell that this is not great, where the researcher uses a subgroup that is easy for them to study. In this case, we are told that the researcher is going to be studying students at a local high school. What areas of bias might this introduce over, say, doing a random or a stratified sample like we talked about? So not anonymous. If we're going to like go to the high school and interview people, that might introduce bias there. I totally agree. Bias on the age. So we said there might be generational bias already. Maybe adolescents are going to answer differently than adults. And we'd be getting a disproportionately large number of adolescents. I think that'd be good. And then there was another one that was interesting that we brought up during the stratification. Yeah, location, right? If we are looking at a local high school, then great, we get maybe a look at what teenagers in that town think, but can we then make claims that we know what is going on with the larger US population? No, probably. Very, very good. Okay, we're gonna finish up point 2 tomorrow, get started on 2.4. 2.1, 2.2 classworks are both up, so you should be able to work on both of those. The classworks for the extra credit, if the quiz is Monday, when are the classworks due for extra credit? Monday, yeah, quiz is going to be on Monday, not on tomorrow. Quiz, by the way, is just going to be like a quick little vocab, or not, maybe not quick. It's just a vocab quiz. Again, not a whole lot of computation that we can do here, but just like, do you know what nominal is? Do you know what ordinal is? So on. So quiz on Monday, not tomorrow. We haven't finished 2.2, so it doesn't make sense to have that. And then the classworks, if you want the extra credit on the quiz, should be finished by before class for that particular day. Any questions for me before we're finished for today? All right. So hold on for just a moment until the bell, and then you guys will be good to go. All right, have a fantastic rest of your day, guys.